Look, we've all been there, right? It's 3 a.m., your pager is screaming at you, and you're just sitting there staring at a failing pipeline. Why? Because someone made a tiny UI tweak that broke a functional test, or maybe a server config drifted just enough to completely take down staging. It's the painful reality of traditional software delivery. But what if I told you that all this manual toolchain friction is finally coming to an end? Because generative AI, it's no longer just a shiny new tool. It is a fundamental catalyst. It's reshaping how we write code, how we test, and honestly, the very craft of development itself. It's literally the catalyst that's going to end that 3 a.m. suffering.
So, welcome back to The Explainer. I am so thrilled you're here today because we are diving deep into part 2 of our source material, Generative AI Transformations, covering pages 103 through 180. We're embarking on a pretty fascinating chronological journey straight through the software delivery lifecycle. We're going to look really closely at how these transformations are paving the ultimate path to a NoOps reality. Imagine a world where your pipeline practically runs itself, and you actually get to focus on what you love doing, building incredibly great products. Okay, let's dive into this. Our roadmap today covers 6 core areas. 1, the generative AI catalyst. 2, coding and unit testing. 3, self-healing system tests. 4, automating infrastructure and data. 5, AI-orchestrated CI/CD pipelines. And finally, 6, preparing for NoOps. Step by step, we're going to see how AI steps in to inject autonomy at every single bottleneck. Section 1, the generative AI catalyst. Here, we're officially moving from manual friction to an autonomous flow. AI isn't just a fancy autocomplete anymore, it's practically a team of specialized agents working right alongside us. Section 2, coding and unit testing. This takes us to the very first pillar of the lifecycle, tackling the sheer drudgery of writing boilerplate code that's bogged developers down for decades. We are completely shifting to a modern dynamic here. Intelligent pair programming living directly inside your IDE. Picture an AI entity sitting right there beside you, like GitHub Copilot. The AI essentially front-loads all the relevant snippets and templates. And the best part? It allows you, the developer, to stay entirely locked in your creative flow state, focusing purely on the business logic instead of wrestling with syntax.
This kind of in-platform synergy, it's an absolute game changer. Because the AI is deeply contextually aware of your specific code base, it just handles the boilerplate for you. It spots edge cases you might have totally missed, and, this is huge, it generates the companion unit tests on the fly. You're rapidly spinning up both the application code and the validation logic without ever having to leave your editor.
Section 3, self-healing system tests, because as we all know, unit tests are really just the beginning of the QA phase.
We've all felt the deep, soul-crushing frustration of maintaining functional tests. You change the color of one single UI button, and suddenly, boom, a dozen fragile automation scripts completely shatter. The contrast here is just stark. Traditional testing comes with this massive maintenance tax because it relies on those rigid, brittle locators. But with AI-driven testing tools like Functionize, for example, the AI actually observes real user flows. When the app evolves, say your checkout button moves a few pixels to the left, the AI dynamically adapts. It literally self-heals the test script. That crippling maintenance tax that constantly drags down continuous deployment, gone. And if we take this a step further into the future with tools like OpenAI Operator, we're looking at a true black box approach. It doesn't even rely on traditional APIs or DOM locators. Instead, it sees the application exactly the way a human does. It navigates the UI autonomously based on high-level concepts. Imagine just casually telling your AI, hey, go test the checkout flow for our new promo code, and it just figures it out. No way, right? But that is exactly where system testing is headed. Section 4, automating infrastructure and data. Let's zoom out of the application code and look at the broader system, where provisioning test data usually creates massive bottlenecks. 60%. That is how much AI can reduce your infrastructure provisioning time right now, today. Just let that massive ROI sink in for a second. By using AI to write your Terraform or CloudFormation scripts, you are completely supercharging your deployment velocity. Let's look at how this builds into a real AI-driven infrastructure as code workflow. Developers can keep that stay-in-the-flow mindset. You just use everyday natural language right in your IDE. You type something like, create an EKS cluster with auto-scaling. The AI translates that, generates the Terraform code, commits it, triggers the CI/CD pipeline, and provisions the cloud infrastructure. And the whole shebang is monitored by telemetry, feeding straight back into your unified insights dashboard.
But the AI's job doesn't stop once things are built. For genuinely smarter infrastructure, the AI continuously monitors the live environment. It spots drift, say someone goes in and manually tweaks the security group, and it auto-corrects it right back to the baseline. It uses predictive scaling to prep for load spikes way before they actually hit. And this is critical. It safely automates data masking for PCI and HIPAA compliance, meaning you can spin up staging environments using fully anonymized production data almost instantly. Section 5. AI orchestrated CI/CD pipelines. Now we transition to the macro view of the deployment pipeline, where AI handles the heavy orchestration. So how does an AI pipeline actually flow in practice? Well, when code is merged, the AI kicks in with intelligent test selection. Instead of blindly running a massive 3-hour test suite for a tiny typo fix, it analyzes the specific code changes and runs only the necessary tests. Then, during deployment, its anomaly detection is constantly watching the telemetry. If it spots a sudden spike in latency during a canary rollout, for instance, it automatically hits the brakes and proposes a rollback. It's incredibly smart.
Section 6. Preparing for NoOps. Because achieving this fully autonomous pipeline requires incredibly organized human-AI collaboration and strict rules. The absolutely crucial point here is that you have to establish a clear mitigation playbook and strong platform guardrails. You can't just let AI run completely wild, right? You need these boundaries to harden AI from a cool experiment into everyday muscle memory. Notice how the really safe actions like fixing typos, pushing simple drift patches, or known self-heals are perfectly fine to auto-merge. But high-stakes actions, things like database schema changes or moving real production data, those absolutely 100% require human review. It's all about building trust through very transparent boundaries. And let's be real, none of this multi-agent synergy works without solid telemetry. For AI to actually make good decisions, it needs a standardized cloud-native data foundation that tracks every single build, deploy, and AI action. Centralized data platforms like Opsera provide the unified insights you desperately need to make NoOps a reality, ensuring you have total visibility across every tool and every stage. As we wrap up this explainer, I really want to leave you with a provocative thought. As we enter this incoming NoOps era, will your team manage the code, or will you manage the AI that writes it? You see, the last mile of human judgment, it isn't disappearing at all. It's just shifting. It's moving away from tedious manual execution and towards strategic, high-level oversight. The future of software delivery is moving at machine speed, and frankly, it's time to decide what your role is going to be in it. Thanks so much for joining me on this deep dive into the AI DevOps transformation. Keep learning and keep building.